Mast Academy is building a new batting cage in the shape of a box with a square base and has a volume of 250 cubic feet. The wood for the base costs $5 per square foot. The net for the roof costs $1 per square foot, while the net for the sides costs $1.50 per square foot. What are the dimensions of the cheapest batting cage? The first step is to find the given equations, or the secondary equations. Volume equals 250 feet cubed, which is equal to x cubed y. The cost of a base equals 5x squared. The cost of the roof equals 1x squared. The cost of the sides equals 1.5xy. The surface area equals 2 times x squared plus xy plus xy, which is also equal to 2x squared plus 4xy. Next step is to find the primary equation. This is what we will be optimizing. The cost of the surface area equals 5x squared plus x squared plus 1.5 xy times 4. The cost of the surface area equals 6x squared plus 6xy. The next step is to find the first derivative of the cost of the surface area. But to do that, we need to solve for y, so there's only one variable. To solve for y, I use the volume equation. Y equals 250x squared. Then I plugged it into the cost of the surface area. The cost of the surface area equals 6x squared plus 1,500 divided by x. Then I found the first derivative. The derivative of the cost equals 12x minus 1,500 x to the negative 2 power. Then I put all of it over x squared. To find the maximum or minimum, in this case minimum, I solved for the critical points of the first using the first derivative. I made the first derivative equal to 0 and the first derivative undefined. I made 0 equal to the numerator and 0 equal to the denominator, and found that x equals 5 and x equals 0 are the critical points. X equals 0 is not possible because you can't have a volume of 250 when one of your sides equals 0. Next, find the second derivative to prove that the critical point that you found, in this case x equals 5, is indeed a minimum or a maximum. In this case, it would need to be a minimum because we're trying to make the cheapest batting cage. Once I solve for this, I plug in the critical point that I had found earlier, which is x equals 5, and prove that all of it is positive, which indicates that the function is concave up, meaning that this is a minimum point. We now know that x equals 5 is the minimum point. You plug that back into what we found for y, and you get y equals 10. The dimensions for the batting cage that Mast Academy is planning to build is 5 feet by 5 feet by 10 feet, or x equals 5 and y equals 10.